Thanks everybody for joining us today for a presentation on drainage systems and resilient infrastructure. This is a meeting that's hosted by the Mississippi section as opposed to one of our branches. We've been kind of mixing it up a little bit with COVID-19, and this is one of the results of that. So I wanted to let you guys know that I'm going to mute everybody. So if you have any questions, please put them in the chat box that is on the side of your screen, and we'll take you can type a question at any point, but we're going to answer those at the end of the meeting, unless Don sees one that he feels should be answered immediately. So I'm going to introduce our speaker, and then I'm just going to pass it on over to him. I do want to say at the end of the presentation, there are going to be 3 questions that you'll need to email me a response to. So I'll put the email address that you need to email and the 3 questions in the chat box on the side. And when I get your response, I'll send you your PDH. Don Conrad, PE, is a technical resources engineer for Forterra Drainage Pipe and Precast, where his territory includes Louisiana and South Mississippi. He holds a Bachelor's of Science degree in Civil Engineering from the University of Tennessee and is a registered professional engineer in the state of Virginia. He has been employed with Forterra/Hansen for 6 years, and he has 15 years in the water, wastewater, stormwater pipeline industry. So thanks for being here, and I'm going to pass it on over to Don.
Jennifer, I'm not
Yes.
advancing for some reason.
Can you try it one more time? Are you clicking your mouse or clicking the keyboard?
Just my arrows.
Try to click your mouse.
Oh, there it goes. All right. There we go. Okay. All right. Welcome, everyone. Appreciate you all joining us today. Hold on. Want to get back. We're going to discuss drainage systems and resilient infrastructure, how that works together. As Jennifer mentioned, there'll be some answers to some questions. I'll make sure that when I get to those particular slides, I'll certainly let you know what they may be. So, all right. Yeah. There we go. All right. Our infrastructure agenda today, resilient infrastructure, is number 1, we're going to define it generally, what resilience means. Then we want to understand how it can be measured. You're also an English major. We go to the dictionary. There are actually 2 definitions. One is capable of withstanding a shock without permanent deformation or rupture. And the second is tending to recover from or adjust easily to misfortune. And that's certainly with our infrastructure, no matter what it might be, whether it's pipeline. This is the first question is off of this slide. I wanted to show that there are several universities in the country that have programs directly instruction on resilience. One at the University of Illinois, University of Georgia, one of our SEC schools. They have a PhD in engineering, Georgia Tech, and they have an infrastructure system research, and then Vanderbilt up in Nashville. They have a master's degree in risk, reliability, and resilience engineering. So I'm sure there are other universities throughout the country that have resilient programs, but these are 4 that we looked at. The importance of resilience. Number 1, we want to improve the overall quality of the infrastructure systems. Secondly, we want to reduce long-term costs. Many times you might design something, but you need to, for the short term, but long term, as much as we spend. Can everybody hear me? I just got a note.
Yeah, maybe Steven's the only one who can't hear.
There's another one too. Okay, so now we're back, I guess. Okay, so the second topic is reducing long-term costs. And when you look at a project, of course, you want to look at not only the design and the construction, the initial, but also in terms of maintenance and cost down the road, again, from misfortune that may come about. We want to improve resistance to disasters, and these are becoming more frequent and more intense. We look at, and you all just went through this, Jennifer just went through this for 2020 for the Mississippi Infrastructure Report Card. This is the last one. This is the national report card. And our grade, unfortunately, on the national scale is in 2007. A D plus this year as well in Mississippi. So we haven't made much progress, unfortunately. The 2013 grade nationally was a D plus as well. So even on the national scale, and this is based on something. This gives you an idea of the funding gap. You can see all the systems that are there. The funding gap, if you look, and this is from 2016 to 2025, 10 years, the funding gap is a little over $2 trillion. And that's quite a sum of money. And being a supplier and watching what funding is coming from the federal government and from the states, I don't see that making up a lot in that gap. This is from 2018, and we know Congress struggles all the time, but they struggle to find a way to plug the shortfall. Since $2 billion to the Highway Trust Fund. However, if we want to maintain those current spending levels, the lawmakers need to approve an additional $107 billion from 2021 through 2026. And the key here is to look at resilience. You save a little today. A lot of times the low-cost material choice is the first choice. And of course, we all are aware that the majority of the time, the low bidder, the construction company that's the low bidder, is going to get the job. And sometimes that's okay, and sometimes it's not. And I'm sure all of you all are aware of the different construction companies throughout your state, the ones that do a good job and some that may not do a good job. So the low bidder, even though it's what we want from a cost standpoint, sometimes it comes back to get us later. And then reduced inspection all across the board. Um, Mississippi DOT, of course, has their own inspection. Some of your firms probably do some of that inspection, but my understanding is there's more inspection and inflation as you might want. And of course, if these occur, then you can pay a lot more tomorrow. Number one, premature failure. Both of these are. We had a situation with Mississippi DOT in Brandon just a couple of weeks ago, where they unfortunately they had some concrete pipe that had been in the ground for 60 years, and the joints, because of the soils around Jackson that move, and you all in Jackson are certainly aware of that, especially if you're a geotech, that they decided to take that out, but they got 60 years out of the pipe, so that's pretty good. And then, of course, as I mentioned, the emergency repairs, and you have to look at everything when it comes to an emergency, because you have to close the road and do the repairs as well. So there's issues with the traveling public that don't even surface with the dollars that you actually have to use. And what happens is it's sort of like a parking meter. You know, you can get by with not putting money in a parking meter. You might get by 15, 20 times. But then at some point, you may end up getting a parking ticket, and that can be $40, $50, which will well outweigh what you may have paid in parking along the way. Also, our phones. Another situation that we have is our phone. Almost all of us, I guess everybody that I'm aware of, uses some sort of a case for their phone, because inevitably we're going to drop it. And even sometimes the case does not do well, but that cost for the case certainly outweighs what might happen if you drop your phone and have to either replace it or put a new screen, whatever the case may be. When we look at resiliency, and this is from an article, and it's out of Canada, shown down at the bottom, that their equality was resiliency equals future proofing. And their definition of future proofing is defined as the ability of an asset to continue to be of value into the future. And that's important. The assets government, and it's important because the asset, they want it to continue to be of value. And it also, when you have resiliency built in and you future proof, it's required to ensure that taxpayers are being provided with value for their money. And the public certainly is expecting that today. This is from the National Center for Environmental Information. This is from 2019, as you can see, and this was the weather $1 billion. Each of these disasters shown here was $1 billion last year. And you can see, of course, we all heard about the fires out in California. We don't have to deal with that very much in Louisiana and Mississippi, thankfully. Texas does have an issue, but some of the others, and you can see the severe weather that was shown there, and tornadoes also. And obviously, and of course, the tornadoes in April, and it was quite unique. I'm sure you're aware you had 3 EF4 tornadoes in a week, and that's very unusual. Also, one of them, I don't remember what day, but it came very close to our plant in Prentiss, Mississippi. Prentiss is about halfway between Jackson and Hattiesburg, and we were very fortunate. There was no damage at the plant. However, a lot of the employees had damage at their homes and their property. So it really held us up because we had a lot of people out, and not only that, of course, with COVID, the same situation. This is some of their information. You can see they've gone back all the way into the 80s. And you can see the numbers, and of course they just keep getting bigger, and the number of events and the number of dollars keep getting bigger and bigger. You can see $1.1 trillion, quite a bit. And then this year, they didn't have complete numbers, but as of April, there had been 2 events that were over $1 billion, and it could have very well been your tornadoes in Mississippi. Could be one of those. I do not know. I didn't see the number on that. This is from 2017. You can see all kinds of issues. Again, the wildfires out west, tornadoes here, the hurricane that hit Texas, that was in 2017. So there are all kinds of opportunities for problems. 2018, through January through September, same situation. Tornadoes, fires, hailstorms, all kinds of different natural disasters. So the natural adverse events, and of course we're very familiar in both Louisiana and Mississippi, the flooding, extreme heat, wildfires, earthquakes, tornado, and hurricanes. And those, almost all of those, can affect you and can affect the infrastructure that you have designed and built over the years of your careers. Also, of course, we have man-made adverse events. We have system overload for one reason or the other. We also have oil and chemical spills, vehicle accidents, and then terrorism and vandalism. Thankfully, we see more vandalism terrorism. This is from the University of Buffalo. There's a PhD there. He came up with this triangle, this 4 R's of resiliency and resiliency triangle. And the point is, you can see over on the left, on the vertical axis, you've got the condition of your structure, and then you have time on the right, and then you have an event, and then a functional level. So he looks at this. One thing to keep in mind, I did a little research on this. The gentleman that did this was looking at earthquakes. He was not looking at events that typically we would see here in the Southeast. And that's what the triangle looks like, of course, you see the event, and then the condition of the infrastructure goes down. You have a period of time, and then it gets back up to a functional level, and then finally, hopefully, back to the initial structure quality. The first R that he talks about is robustness. And this is a higher level of initial quality that's able to withstand unforeseen demands. And it's important for all your systems. Again, it makes no difference. Most of what I'm going to talk about is drainage, but whatever systems that you all are designing, they need to be robust and of a very good quality. And you can see on his triangle here, when you talk about robustness, you may increase that condition of the structure ahead of time, which results in that resiliency triangle being smaller and the time frame, which is most important, being shorter as well. Redundancy, the definition is a measure of inbuilt sustainability that can keep infrastructure functional during event. And it depends on, again, what you're building. In his case, looking at earthquakes, of course, he was more concerned about how buildings and external structures could be built with redundancy to keep that from happening. And you can see if the redundancy, if it's built in, then you can see the function level hopefully will be higher. You won't have as much of a triangle there to get back to a normal condition for the structure or for the infrastructure. Resourcefulness. This is more of a operational standpoint from the owners, that they are able to minimize and contain the negative the adverse event. And you can see, again, if they're resourceful and they're ready, then everything gets back to normal pretty quickly. The one analogy I guess I can use, and it's not in Mississippi, here in Louisiana, was the pump system around New Orleans during Hurricane Katrina. The resourcefulness is very important to minimize those negative effects. And then the last is rapidity, which is the capacity to respond in a timely and efficient manner before, during, and after an adverse event. And it's important to be able to get in and get things back to normal. Again, during Hurricane Katrina, that did not happen. And of course, some of that happened on your Mississippi Gulf Coast as well during that event. To respond is organized and thought about beforehand. So I want to back up 1 minute. I did this one, as I mentioned, this was for earthquakes. I did find from the American Road Builders and Transportation Association, they have a 4 R's of resiliency for transportation. And it was a little bit different, obviously, for robustness. They talked about having movable barrier technology and work zones to be able to get things back quickly. Redundancy, their topic was to replace trusses with cable stayed and network arches on bridges. They were speaking bridges directly. Resourcefulness. It was very interesting. They talked about mapping the GIS systems and mapping and redirecting traffic. And that's obviously important as well. And then the last, rapidity, they discussed. And one thing that we in the precast industry push all the time is accelerated bridge construction. And we work through the American Concrete Pipe Association and through the Federal Highway Administration on accelerated bridge construction. Now, the drainage systems, where does it fit into the infrastructure? And you may ask that question. The key is that as far as drainage, it's not really a category of its own, but it's part of a broader system, and it affects almost every other category of infrastructure. And you can see here with this pie chart, the highways and bridges are one of the largest at 21%, and then ports and logistics. And both of those are very important to you all in Mississippi. I know your ports are quite active and bring a lot of dollars to the state as well. Then we look, you've got urban mass transit, electricity, everybody, lots of infrastructure to do with that. And then oil and gas. And then, of course, and we don't, in our business with the drainage, water and wastewater as well, we don't get involved with that as much. And of course, the other folks that are big is railways. The railroads are very dependent on getting proper drainage around their systems. And you can see these blue, we don't have a percentage, but that's just a rendering to show that drainage is indeed with all of these, but it's a very small part. Now, adverse events affecting drainage systems, there are many. We looked at them earlier with the $1 billion events, but we have, of course, fire, flooding, vandalism, earthquakes, shifting soils. That hits home in the Jackson area for sure. Thankfully, we don't have to deal with freeze-thaw very often. And vehicle accidents, everyone has to deal with those in the aftermath of those, and then extreme temperatures. And certainly Mississippi has extreme temperatures, mainly on the high side, but certainly extreme temperatures are part of it. We're going to look at flooding. Of course, pipe, any kind of flooding affects the drainage pipe. I have some videos here. This one's in Wisconsin. Luckily, it doesn't appear, based on this video, that the roadway was damaged, at least not major damage. But the culprit here, of course, is the pipe in this case. And so that occurs rather frequently. This next video is from East Texas. It has some rather colorful discussion about what's happening. So And I don't see it on either end. I didn't see any head wall. There was no head wall on this pipe, and obviously that creates issues if you just put pipe in and it doesn't. It's not sized properly. Without a head wall, it can create problems, and you can see here. Obviously, this was a serious rain event that this occurred. So then no video here, but just a picture. A 50-foot wide section collapsed, and cars unfortunately ran into the failure. And that always is an issue that we need to be aware of. And of course, the thing about it is, it doesn't you don't see it till you're on it. Especially, this looks like it was at night. This is another one. This one's in Michigan, and you can see this. The roadway is washed out completely. However, the concrete pipe is still in place, but obviously the pipe was not able to take the this rain event for sure. And you can see that the roadway went away, but the pipe stayed. But the pipe certainly didn't help matters by not being correctly sized. Now, we don't know all of the details about this, but obviously this is a pretty serious failure. Again, and typically you can see it's a 2-lane road. We can't see whether there's head walls on either one, head walls or wing walls, whatever. But it occurs to every type of pipe. This is one up in Georgia. This was back in 2009. It was corrugated metal pipe. The key here is, and I know the majority of the engineers, I would venture to say all the engineers on this call or on this webinar, you see there's no reinforcement in that head wall. Now, I'm pretty sure that any engineer that would design that head wall would put in some rebar, some sort of reinforcement in there. And my guess is the contractor did not put it in. He wanted to save some money. So even with a head wall in this situation, you can see that you have issues all the time. And of course, this is up in the Atlanta area, where they have that red clay, and when the water gets started in there, it erodes quickly. So the system obviously failed, and then the biggest problem here was the detour around this road. It caused a lot of public issues with the detour. Here's another one up in North Georgia as well. This one, however, made it through. It's 2 lines of reinforced concrete pipe, but more importantly, there was a properly constructed head wall. You can see the head wall there, even though the debris that came down with the flood, it did not damage. So this one obviously has some reinforcement in it and was designed and installed properly. In this case, they had to do some earthwork around it, of course, remove all of the debris, and they were back in business with no detours required on this one. So flooding. This one, and this is another on this slide. Some of these questions are answers, and Jennifer, I didn't think about it. I need to give them the questions as well, correct?
Yes, you already did the first one, but you did not do the second one.
Yeah. Okay. All right. All right. For flooding, the question. Well, let's go through it. Number one, a resilient solution for that is to build a proper head wall to provide scour around the inlet. And as we've seen in these previous pictures and videos, that's a proper head wall is important. One thing we have, I say we, the precast concrete industry, we offer precast head walls and wing walls and aprons and all, but most engineers, probably 95% at least that I have dealt with, prefer to have the contractor cast it in place because of issues that may occur if things don't line up, and I certainly understand that. But we certainly recommend that you put a head wall around their pipe. Second is, of course, to use riprap to reduce the velocities. Non-floatable material, and then oversize the culvert to avoid a submerged inlet. Now, that last one, I'm not really, well, let me put it this way. If you have to oversize a culvert, it's going to cost you a lot more to start. So hopefully you can use the other three topics there to make sure that if there is flooding, that you don't have those issues. And the question from this slide will be, of course, there are 4 solutions to flooding, and you need to name one of those to send it to Jennifer. So flooding, we looked at that, and that obviously in Mississippi, that's an issue for you all. Wildfires. Wildfires are not typically a problem in your state in Mississippi, or either here in Louisiana where I am, but they are an issue. This is from Stoneburg, Texas. This was back in 2009, and they had wildfires. I'm assuming Stoneburg must be in the western part of the state, but a wildfire ignited a triple line of 60-inch HDPE pipe, and the road collapsed. You can see the collapse there. And emergency response vehicles, there was one that ended up down in the ditch, and then a resident, and you can see in the picture on the upper right, ran into it as well and was injured. Thankfully, nobody got hurt seriously, but the bigger issue for them from a brush fire situation is that there were only, from that little town, there's only 2 evacuation routes. And so when this occurred, have a difficult time getting into this little town. Now, as a result of that brush fire, the Texas DOT revised their use of plastic pipe. The restrictions that they put on roadways with current ADT less than 2,000 vehicles per lane. The inside pipe diameters no greater than 36 inches, so they limited that the diameter. And multiple pipe installations will be limited to a maximum of 2 adjacent pipes. And then for pipe installations beneath and adjacent to the road, safety in treatment. And of course, the reason for that is that the concrete, of course, won't burn. So if a wildfire does come through and it does get to the culvert, it's not going to catch the plastic or whatever other material that might be there. Interestingly, I attend if some of you all probably have attended this, the Mississippi DOT has a maintenance conference every year. Unfortunately, it's been canceled this year. It was canceled this year, but it's been very interesting talking to all these maintenance folks from around the state, and they use a lot of plastic pipe, flexible pipe, for driveways, which certainly understandable to do that. But they said a lot of times the issues that they have is the homeowners in the fall will rake all their leaves into the ditch line. And of course, very interesting. Now out in California, and of course they have really real issues with wildfires out there. Of course, they have extreme heat. You can see this one was in 2017, destroyed homes, killed people, and it melted the plastic storm drains. Again, the collapse, and then the problem that they have out there, of course, they have lots of mountains and lots of relief, and so after it rains, then after the burn, and then it rains, then they have flooding issues on top of that. So they have the worst. And then these are from Arizona. Both of these, again, mostly in subdivisions, and you can see the HDPE that burns and will collapse. So for wildfire, the resilient solutions, as TxDOT did, you use non-flammable end treatments and possibly use non-flammable culvert material. And then, of course, this is a little cartoon for man-made adverse events. So we'll look at some man-made issues. Adverse events, obviously, for pipe is fuel truck accidents. It doesn't necessarily have to be a fuel truck. It can be any kind of a truck. I have a video here that you can see. This is as you can see, it's in Houston, Texas. And you can see from here, of course, this was where the truck actually wrecked. But the issue that they had was very serious. Is all of the fuel in that truck, and apparently this was a fuel truck, a tanker. The fuel truck actually, when the tanks burst, the fuel got into the drainage system. In this case, the drainage system was concrete, but if you noticed in that video, you saw some flames out away from the main area. And what that was, the fuel got all the way down, and then when it blew, when it caught on fire, it blew the manholes and the manhole tops completely off. So that's the issues. You can see over on the right-hand side, right there is one. There's one as well. Those are actually the manholes. You can see the fuel burning and coming right up and blew the manholes up. Yeah, I want to back up a minute. I know, I know you all certainly saw whoever put that one video together in Mobile. For some reason, they put LA instead of AL. So that was Mobile, Alabama, uh, there. But of course, the fires, those are issues that we deal with, especially not so much for you all, but especially here in Louisiana. We seem to have our more than our share of truck wrecks. So the solutions for this is to use a non-flammable drainage material. And essentially that's all you can do. But obviously you can't predict when you're going to have an incident. And then we'll talk about vandalism as well, and that occurs on a regular basis. So you can see, even though these guys didn't intend to do that, they did create a problem. And then this one was in Washington, D.C. You can see the smoke coming again up out of from a manhole. And in this case, apparently they did it, it was intended, according to this, this news article here that I'm not sure why they would do that, but apparently they did. So vandalism for resilience, resilient solutions for that. Number one, restrict access to culverts using trash guards and locked manhole lids. Now, of course, the issue is if you put a trash guard over a culvert, that is going to affect your flow, and all the material, the debris and all is going to get caught. So it's sort of a catch-22 for that one. Use a non-flammable, tamper-resistant pipe material. That's the two ways you can do that. And again, this is the third question. And the question, of course, is there are two resilient solutions for vandalism, and you need to name one and send that to Jennifer. So we look at future proofing and innovative techniques. There's new ways of doing things. Again, you can design for a higher volume and more frequent events. Again, that depends on what your owner is looking for and what they're willing to pay for. So it's a balancing act for you all as design engineers, and then of course to use robust materials. And of course, we talk about precast. Our resilient infrastructure is number one, of course, it's non-flammable. Number two, it's heavy. That's, of course, the contractors complain and say, well, your pipe's too heavy, but it is resistant to floating. You don't have to worry about it floating out when you have a flood. It is a robust and a trusted and proven design. And of course, we have a proven history of long-term performance. We have many installations in Mississippi that have been there for excess of 100 years. So we provide resilient materials to future-proof our infrastructure. And that is the end of the presentation. If anybody has any questions, certainly I'll be happy to hang on and answer them.
Thanks, Dawn. I am typing the questions. Oop, thought I was typing the questions.
Yeah, I saw them.
So there are 3 questions. If you guys could please email me, it's mississippisectionase@gmail.com. The 3 questions that you'll need to answer to get your PDH are: number 1, there are 2 universities in the SEC that offer advanced resiliency degrees. Who are they? Number 2, there are 4 resilient solutions to flooding. Name one. And number 3, there are 2 resilient solutions to vandalism. Name one. I don't see any questions. Does anybody have any questions to ask Dawn?
I I know I didn't do that well. Got to be some questions.
I love the fire, all the fire videos.
Yeah, they're pretty awesome. Like unless you're on the owner's end.
True, true. And I would never ever set one intentionally, but they're interesting to watch nonetheless.
Yeah.
Also, the flooding destruction videos are also interesting to watch as well.
I certainly don't. I certainly don't have to tell anybody in Mississippi about flooding. You all have flooding in every area of your state, so.
Yes. Vince asked, can we get a copy of the slides?
Yes, I certainly can. I can. I'll send you a PDF copy this afternoon, and you can forward it to them. And
Okay,
you
sounds
did you
great.
record? Did you record as well?
I did. And
Okay.
this is also recorded, so this will be posted on our YouTube channel. It depends on how long it takes WebEx to finish the recording and send it to me.
No problem. But I'll send that PDF to you later this afternoon.
Okay. Yeah, I'll send that to you, Vince. If anybody else wants a copy, just let me know. Awesome. Well, if there's nothing else, thanks so much, Dawn, for talking to us about resiliency and infrastructure and stormwater. It's like you said, it's really important in Mississippi, but I know it's also very important in other places as well.
Yeah.
So.
Yeah. Okay. Well, thank
Well,
you so much for having me.
Of course. Everybody have a good Tuesday afternoon. Bye.